Hey everyone, it's Casey from the Montreal Student Network, and today we're going to be talking about constitutional isomers, specifically those found in butane. Now, a constitutional isomer, you have to follow two main rules that I'm going to write out right now. Number one, when you're looking at constitutional isomers, they need to have the same chemical formula. And when we're talking about chemical formula, we're not talking about the one where you expand it all and write CH3, CH2, CH2, CH3. We're talking about the one where you sum up all the different elements inside your compound or your different atoms. So, for example, CX, H, X, and those can be whatever numbers you want, has to be equal to CX, H, X. This would be compound number 1, this would be compound number 2. If they have the same numbers, same number of total carbons, same number of total carbons, same number of total hydrogens on each side, or whatever other elements, if you have some oxygens in there, if you have some nitrogens, then you will have rule number 1 is satisfied. Now looking at rule number 2, they need to have the same chemical formula, but they also need to have different atomic arrangements. The different atomic arrangements means they can't be connected the same way. They need to have different connectivity with different, constitution. There's all arranged differently. So the branches need to be different. They can't just be the same form. It's easier if I draw it out. And we're going to look at butane because butane is the smallest alkane, straight chain alkane, to actually have a constitutional isomer. So we're going to draw it out. There's our butane, the butane that we know. And if you want to draw it out, not in bond line form, in case some of you guys are still new to bond line, and we are going to want to just make sure we count all the hydrogens and carbons to make sure we are, make sure that the other constitutional isomer that we're going to be looking at will actually follow the rule of having the same chemical formula. So there is our butane, and we can count that we have 4 carbons, so our chemical formula is C4. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. So that's our chemical formula right now. Now, is there any other way we can arrange this structure to have a different atomic arrangement? Well, we can take this guy right over here, and we can move him up top over here. Now, will that keep our chemical formula the same? Let's find out. We'll draw it right over here. So say we move that branch right there, we'll have this instead. Kind of looks like a peace sign. It's not completed at the bottom. It doesn't have the star. I guess it really doesn't look like a peace sign. So anyways, let's replace the bond line formula, which is right over here, with a bit more structural formula like this, so we can get a better idea of how much carbons and hydrogens we have. I'll move it down right now so we have a bit more space. We can see, so we have our 4 carbons, so we do have the same amount of carbons. Now we're going to fill it up with hydrogens. Remember, carbon needs 4 bonds. The 3 carbons on the outside over here are all connected to one other carbon, so they can have 3 hydrogens to complete the 4. Now that's 9 hydrogens. Where is our 10th one? Let's look in the middle. This carbon is connected to 3 other carbons, so it has room for 1 more hydrogen. And there we go. We have the same chemical formula, C4H10, and we have different connectivity, different arrangement. The carbons are arranged differently, and there we can say that these two guys are constitutional isomers. Check between these two guys over here. Now, you can't just look at one compound and say it's a constitutional isomer. It's a comparative term. Just like you can't look at one person walking in the street and say that person is a cousin. You need to say those people are cousins or those compounds are constitutional isomers. So, looking at the two, how do we name this one over here? We know that when it's arranged in a straight chain, let's go down and start a little new canvas over here. We know that when 4 carbons are arranged in a straight line, this representation, remember, it's similar to this right now. It's just basically with the bonding pattern that happens because it is a tetrahedral arrangement. It does look a bit zigzagged, but for all intents and purposes, this is exactly what we're looking at, the straight chain. When we're looking at straight chain, we just call that butane or N-butane. N really means normal or just straight chain. It's not a term that's really UPAC accepted when naming. We'll just, for the most part, we'll call that butane. But to give it two different names, we'll have butane when it's arranged like this, but when it's arranged like this guy over here, or in other words, it has the connection of a pattern like that, we will call that, let's get down right here, isobutane. Right over here. So we have our different names: N-butane, normal butane, arranged in a straight line, still 4 carbons, or isobutane arranged in the only other option you have, because there's really no other way to arrange this. It only has one other structural isomer. If you decided to take this branch over here and put it I don't know, right over here, well, you're just gonna, you're gonna end up having the same N-butane. It's just gonna make it shifted over one, but you're really gonna have the same formula, because you need to know, just writing something backwards, it doesn't make it a new compound. It's still the same compound. This is the only other option. Once you go up to 5 carbons, pentane, then you're gonna actually start having more options for constitutional isomers. But for the most part, butane, it will only ever have one that you need to worry about. So those are the 2 rules that you really want to look at. Does it have the same chemical formula, and is it arranged differently? I mean, if it's not arranged differently, you're probably looking at the same compound, and it's just an identical compound is how you would classify it. So just count all your carbons, count all your hydrogens, and count any other element or atom you have in your structure, and then see, are they arranged differently? You might get tricked. Your teacher might try to put something that's just backwards, and it might look like it's a bit different, but in reality, it's not. So thank you very much for watching. Hope you enjoyed the video. If you have any comments, please leave them below, and I will answer you as soon as possible. Have yourselves a great day.